we can classify functions as even, odd, or neither. To determine if a function is even, we want to check its graph to see if it's symmetric with respect to the y-axis. That just means that you can fold it on the y-axis and it would fold on top of itself. So for instance, this point 2, 1 would get reflected over to the point negative 2, 1. So for every x, y, I'm going to have a negative x, y. For an odd function, it's symmetric to the origin. So you can see this point 2, 1 that is reflected across the origin. For every x, y, you're going to have a negative x, negative y. So we had 2, 1, and we had negative 2, negative 1. Now a really easy way to spot an odd function is it's the same graph upside down as it is right side up. So if you turn your note sheet upside down and compare it to the graph here, you'll see they still look identical. And then we've also been working with symmetry or reflection in the x-axis. So you'll notice that again, if I had the point 1, 2, when it got reflected, it would be 1, negative 2. That would be two x values the same. So that's not a function. That's one example of neither. But if a function is not even or it's not odd, then it's neither. So let's look at a couple of those. Looking at this first graph, can you fold this on the y-axis and it fold on top of itself? No. Can you turn it upside down and have the same picture upside down as you do right side up? Yes. So what is this? This is odd. All right, look at the next one. For the next one, can you fold this on the y-axis and it fold on top of itself? Yes. So what does that make it? Even. All right, and then look at the last one. Can you fold it on the y-axis and it fold on top of itself? No. Can you turn it upside down and it be the same picture upside down as it is right side up? No. If you look at your y-intercept, when you turn yours upside down, your y-intercept is a positive value. Mine is a negative value. So those are not the same. So that would be odd, even, and neither. So that's how we can look at a graph to determine. We also have an algebraic test we can use to determine. And that test is plug a negative x into the function in the place of x. If you get exactly what you started with, it's even. If you get the opposite of what you started with, it's odd. Okay, if you notice over here, when we put a negative x in the place of x, we get the exact same y that we started with. So again, when you plug in a negative x, if you get exactly what you started with, that's even. But here you'll notice that when we put in a negative x, we get a negative y. We get the opposite of the y that we started with. So when you get the opposite of what you started with, it's odd. So let's look at those same three functions. We already know what they're supposed to be, but let's see if algebraically we can get the same conclusion. All right, so let's put a negative x in the place of x. If you take a negative x and cube it, what do you get? Negative x cubed. And then minus a negative x would be plus x. So if you'll notice, that's definitely not the same function we started with, but it looks like it might be the opposite. To check that, we need to factor out a negative. So when you factor out the negative, you can see, yes, that's the opposite of the exact same function I started with. So when I get the opposite of what I started with, it's odd. All right, let's plug negative x into the second one. So negative x squared would give us a positive x squared, and then we have our plus 1. So that is the exact same function that I started with. So this one would be even. All right, then let's try the next one. Put a negative x in the place of x. And again, when you cube a negative x, you get negative x cubed. Now I have to be really careful with this one because it looks like it's odd, but we've already said by the graph we know it's neither. It looks like the opposite of the x cubed minus 1 I started with. And so that's why back here in our first example, I recommended to you that you factor out a negative. If we factor out a negative out of this, you'll notice that I have the opposite of this function. That is not what I started with. If you have a negative out in front, it's going to change every sign, not just the sign out in front, right? So it's not exactly what I started with. It's not the opposite of what I started with, so that's neither.